just updated OBS, so hopefully there are no problems. Today I'm gonna start working on the chain data stuff with Rust.
Hello, and
I'm gonna start by following this tutorial here and copying what he does into the thing that I have. Then later, after that, I'm gonna try to uh, transform that code into the thing that I want for my purpose. And before I start that, I'm gonna put the timer here and run the Italian stuff that I created. Oh no. So I didn't do anything with this. I'm not sure why it's giving me an error now. Looks fine here. Italian speak source. I have no idea what happened. Because I didn't do anything with this file. Since last time I streamed, I think. Missing a lib target. I don't know how this is happening because it didn't do anything. Hopefully it will work after I install this. Maybe I deleted something by accident. Maybe it's because it got updated. That could be the thing. Let me change the version here. Yeah, but now it's saying it's incorrect. I think I'm gonna try this. And it's still running the same one. And the thing is, I have no idea what to do. Maybe I'll look at this later and try to start the other one. It's super weird. Maybe I should study the package system from Rust and try to understand what's going on. I think I remember seeing some time ago a video talking about this but it was just for stars, I think. If you use stars on the project, then in the future the project can stop running because you don't have the same version installed. But I don't remember really well if that's possible if you have other versions. And it must be a problem with that because I didn't do anything with the project. Jesus.
Let's talk about Rust packages, crates, modules, and workspaces. So you can think of this floor as a workspace. And on my workspace, I can have multiple packages. Each one of these boxes is a package. Inside the package is this crate. This crate is this cardboard tray that the cold brew coffee's in. And inside the crate is the cold brew coffee, which you can think of as modules. This crate has some modules. So the workspace had a package on it. Package had a crate in it. Some boxes have multiple items in them. The crate had potentially multiple modules in the crate. Let's talk about crates, packages, modules, and workspaces. Now these are really closely related concepts that have subtle differences. When you run cargo new on the command line, you're actually creating a crate and a package. All cargo.toml files are associated with either a package or a workspace. So a cargo.toml file in a package applies to all the crates in that package, and a cargo.toml in a workspace applies only to that workspace. Workspaces are used to group related packages that may or may not depend on each other. One example of this might be a web application that has separate packages for the front end and the back end. All packages in a workspace share a common output directory for build artifacts. Create a workspace by creating a directory and placing a cargo.toml file in it with a workspace section. While you can use cargo new to quickly create the file structure for packages, it doesn't currently appear that you can do so for workspaces. Inside that directory, you can run cargo new to create packages within that workspace. To associate those packages with the workspace, add their names to a list of members in the workspace cargo.toml file. A package consists of one or more crates. Crates can either be binaries or libraries. A package can contain at most one library crate and may contain as many binary crates as desired. The default binary crate is defined by placing a main.rs file in the source directory of a package. The default library crate is defined by placing lib.rs inside the source directory of that package. Additional binary crates can be added to the package by placing them in a bin directory within the source directory. The names of these additional binary crates will be dictated by the name of the root source file. When working in a package that has multiple binary crates, use the --bin argument when invoking cargo run to specify the name of the crate you'd like to run. The binary crate defined in main.rs can be referred to using the name of the package. Use the dependency section of a package cargo.toml to specify the library crates that the package depends on. These dependency crates can exist in the cargo package registry, in a GitHub repository, or in another package of the same workspace. Each crate contains one or more modules. Modules provide logical groupings of functions and structures, as well as control over whether those resources are exposed to other modules. Modules can be defined purely in code by enclosing the contents of that module in curly braces, or they can leverage the file system to establish a hierarchy and separate the code into multiple files. Declare the existence of a module in a separate file by placing a semicolon after the mod clause instead of curly braces. The Rust compiler will look for the module in an RS file that matches the module name. You can define submodules in this file, which refer to files inside a directory named after the module. Hope this overview of crates, packages, modules, and workspaces was helpful. See you in the next one.
Welcome back, Rust gang. If you're new here, my name is Bogdan, and this channel is all about the Rust programming language. If that sounds interesting to you, click that subscribe button for weekly Rust videos. In the last video, we talked about publishing a crate to crates.io, and in this video, we're primarily going to talk about cargo workspaces. Recall that in chapter 12, we built a CLI program that had a binary crate and a library crate. Now, what happens if the project keeps growing and we have multiple library crates? Well, in that case, cargo workspaces might help you organize your project. Workspaces help you manage multiple related packages that are developed in tandem. Packages in a workspace share common dependency resolution by having one cargo.log file. Packages in a workspace also share one output directory and various settings such as profiles. All right, now we have enough of the basic information to get started. So with that, let's get rusty. For simplicity, we're going to create a workspace with one binary that depends on two libraries. The first library will have a add1 function, and the second library will have an add2 function, which our binary will use. To start off, let's create a directory called add and cd into it. Then let's open this up in VS Code. Next, we'll add a cargo.toml file, which will configure the entire workspace. Now, instead
Maybe
of
we should search for sleep, Rust, standards, sleep, library. The results are not very helpful. Maybe it could be because of Windows. Maybe there was a Windows update and that fucked it up. I think that might be possible, actually. Another alternative is just to look for another library, but I think it's worth spending some time understanding this because I didn't really understand in the beginning very well. Maybe the other one has a link as well. It's not the same site. Well, it doesn't make sense to be here because it's part of the standard library, I think. I'm gonna watch a couple of videos about this, and then I'm gonna watch videos on the thread as well that I'm using there, so I understand better the package dependencies, and then I'll test it out other methods.
Having a package section, like usual, will create a workspace section. Next, we can specify the packages in our workspace, which are called workspace members. So to do that, we'll type in members equal, and then brackets. And here we'll type in the path to our packages. First, we're going to specify the path to our binary, which is going to be called adder. So the path is just adder. Next, we'll open up the terminal and actually create the adder package. At this point, we can also build our workspace by running cargo build from the add directory. At this point, we can see that the cargo.log file and target directory were generated at the root of our workspace. And if we look at the adder package, you can see that it doesn't have a cargo.log file or a target directory. Even if we run cargo build from the adder directory, we would still see the output in the top level target directory. Cargo uses this structure because packages in a workspace are meant to depend on each other. If each package had its own target directory, then when you would compile that package, you would have to also compile all its dependencies. So this reduces the amount of recompilation you have to do. All right, next we'll add another package or member to our workspace and call it add1. Then we'll type in cargo new add1 and then dash lib because we want to create a library. Next, let's navigate to the lib.rs file in our new library. And we'll delete this default tests module and add
I don't know, I guess it's creating this file here. I'll go back. Or maybe not.
We're going to create a workspace with one binary that depends on two libraries. The first library will have a add1 function, and the second library will have an add2 function, which our binary will use. To start off, let's create a directory called add and cd into it. Then let's open this up in VS Code. Next, we'll add a cargo.toml file, which will configure the entire workspace. Now, instead of having a package section like usual, we'll create a workspace section. Next, we can specify the packages in our workspace, which
I guess is a different thing.
are called workspace members. So to do that, we'll type in members equal, and then brackets. And here we'll type in the path to our packages. First, we're going to specify the path to our binary, which is going to be called adder. So the path is just adder. Next, we'll open up the terminal and actually create the adder package. At this point, we can also build our workspace by running cargo build from the add directory. At this point, we can see that the cargo.log file and target directory were generated at the root of our workspace. And if we look at the adder package, you can see that it doesn't have a cargo.log file or a target directory. Even if we run cargo build from the adder directory, we would still see the output in the top level target directory. Cargo uses this structure because packages in a workspace are meant to depend on each other. If each package had its own target directory, then when you would compile that package, you would have to also compile all its dependencies. So this reduces the amount of recompilation you have to do. All right, next we'll add another package or member to our workspace and call it add1. Then we'll type in cargo new add1 and then dash lib because we want to create a library. Next, let's navigate to the lib.rs file in our new library. And we'll delete this default tests module and add a public add1 function. Now that we have this library with an add1 function, we can use it from within the adder binary. So let's open up the cargo.toml file within the adder directory. Next, we need to specify that our adder binary depends on our add1 library. So let's scroll down to the dependency section and add our add1 library as a dependency. Cargo doesn't assume that crates within a workspace depend on each other, so we have to make this relationship explicit. Next, we'll open up main.rs within the source directory in our adder package. And notice that when we type in the library name, we use an underscore instead of a dash. Then we can modify main to use our add1 function. Here we're declaring a new variable called num and setting it to 10, and then we have this print line statement, which prints hello world, the number we just declared, and then the number plus 1, and we get that by calling our add1 function. All right, now let's build our workspace by typing in cargo build at the root of our workspace. Next, we can run our adder binary from the root of our workspace by typing in cargo run -p to specify the package we want to run, and then adder. And as you can see, our add1 function worked. Next, let's talk about external dependencies. If you look at the Explorer tab on the left, you'll see that we have a cargo.toml file for both our add1 package and our adder package. However, we only have one cargo.log file in the root of our workspace. This ensures that all our crates are using the same version of all dependencies. So if we add a dependency to our add1 package and we add the same dependency to our adder package, they will both resolve to the same version. Making all packages in a workspace use the same dependencies ensures that the packages are compatible with each other. Let's try this out by adding an external dependency. We'll go to the cargo.toml file for our add1 package and add the crate rand as a dependency. Then we can go into lib.rs and bring rand into scope. And we'll get a little warning here because we're not actually using rand anywhere in our program. Then from the root of our workspace in the add directory, we can run cargo build. This will bring in and compile the rand crate. And if we look at the cargo.log file in the root of our workspace, we can see that we have the rand crate here. And if we go a little bit down, you can see the rand crate is defined here as a dependency. Now, even though rand is a dependency of our add1 package and it's defined in the root cargo.log file, it doesn't mean that we can use rand in any other package in the workspace. For example, if we go into main.rs in our adder package and try to bring rand into scope, we should get an error. If I hover over the red squigglies, you can see that the error is an unresolved import rand. To fix this, we'll need to add rand as a dependency of the adder package inside of adder's cargo.toml file. And now we can bring rand into scope inside main.rs. At this point, both our adder package and our add1 package have a dependency on the rand crate. However, only one version of the rand crate will be downloaded. Next, let's briefly cover testing. Inside our add1 package, we'll add a test module and one test inside lib.rs. The test is called it works, and it simply asserts that calling our add1 function with 2 is going to return 3. Next, we'll open up the terminal and run cargo test from our workspace root, which is the add folder. If I scroll up, you can see that the first section is showing the test that ran for the add1 project. And in this case, we just had one test called it works, which succeeded. The next section is tests that ran for our adder project, and you can see 0 tests were found. The last section lists documentation tests that ran for our add1 library. And as you can see, there are 0 documentation tests at this point. Running cargo tests like this in the root of our workspace will run tests for all the projects within that workspace. If we want to run tests for a specific project, we can do that by specifying -p. For example, let's run tests only for the add1 project. So to do that, we'll type in cargo test -p and then add1. This time we only have 2 sections. The first section is for a regular test. We only have one called it works, and the second section is for a documentation test, which we have 0 of. I'm going to stop here, but I'll give you some homework. If you'd like to continue, then go ahead and add another library called add2, which will have a function similar to add1, except of course it's going to add 2 to the integer being passed in. As we're wrapping up talking about workspaces, one thing to note is that if you want to publish the packages within a workspace, you have to publish them individually, meaning you have to cd into each package, in this example, adder and add1, and then run cargo publish from their respective directories. That's about it for workspaces. So next time you find yourself in a situation where you have a big monolithic project with a lot of components that change together, and you want to make them a little more organized by splitting them out into different projects, then consider using workspaces. Next, we'll talk about installing binaries from crates.io with cargo install. Now, this isn't meant to be a replacement for system packages or package managers such as Homebrew, but rather it's a convenient way for Rust developers to use tools built by other Rust developers and published to crates.io. Note that you can only install packages that have a binary target. Remember, packages can have binary targets and library targets, but specifically we need the binary target because we need something we could actually execute. All binaries installed using the cargo install command are stored inside the installation root's bin directory. If you installed Rust using rustup, then this is the path to the bin directory. Make sure to have this path inside your path environment variable so that way you can run programs installed with the cargo install command. In chapter 12, I mentioned that there's a Rust implementation of the popular tool grep called ripgrep. To install ripgrep, we'll run the following command: cargo install ripgrep. The second to last line here shows where the binary is installed, and in this case, it's in the cargo bin directory, and the executable is actually named rg. Now that the tool is installed, and assuming that your path environment variable is set up correctly, you can simply run rg --help, and you can see the executable is working. One cool thing about these binaries is that you can use them to extend cargo with custom commands. If you have a binary in your path that's prefixed with cargo, for example, let's say that the binary is called cargo-something, then you can run this as a subcommand of cargo by typing in cargo space something. Cargo is designed this way so you can extend cargo without actually modifying cargo's code. That concludes chapter 14 of the Rustling book. If you enjoyed this video, make sure to smash that like button, and if you want to see weekly Rust content, make sure to hit that subscribe button. And with that, I'll see you in the next one.
Trying to think about where is it possibly coming from, the mistake, because I didn't do anything. And I don't think that it would make sense to come from the Windows, because it's saying that the target, lib target is missing, which means there is no files here. So I have no idea what's going on. Maybe if I try to run from one directory up.
Sono I trattino
Damn, I'm
basso
so
am.
dumb.
Io.
But it's weird because this one, the other one, it works if I go into the source folder. Well, I guess the levels are different. Now I'm wondering if, well, it can be possible that it's running this file as well because the CSV is not changing, so. But that's really weird. Oh yeah, because I'm inside of the folder, which is the other project. Oh, and I guess it doesn't have the target, but because I'm inside of the file that doesn't have the target. But I'm pretty sure I remember running this one inside of this folder. So it should work in the same way. And now I think I'm gonna watch. I mean, the good side is that it's still working, but I think I'm gonna watch the videos But it's gonna be hard to find a video that talks about this. Because I want to understand what the command. I remember I did watch a video like this where they said I should use Rust C, but I don't remember which one was it. Where they build up through cargo. Maybe it was on the channel that I just watched. Because I watched so many channels on so many videos.
Hey, welcome back. So one of the things I've realized is a lot of people struggling with what's happening underneath the hood with Rust. It all feels a little bit magical to them. Now, I don't believe in magic. This ain't Harry Potter. So what we're going to do is we're going to break down Rust and we're going to convert it into assembly language. Now, that probably sounds quite difficult, but actually I'm going to walk you through it. It's going to be super simple. And at the end of this, you'll be able to actually convert your own code into assembly language. And it's really going to
I'm
help
gonna
you
watch this video definitely because it's exactly what I want to know. I remember watching videos about the V8 engine from JavaScript from this guy. He's really good. But I don't think he's gonna talk about specifically what I want to know. And I think was
Welcome back, Rusting. If you're new here,
this guy, but I don't remember really well. No, it wasn't this guy. Which one was it?
What's going on, engineers? Rust is a language that I've been wanting to learn for a while, so I thought maybe we could just learn it together. So this will be the beginning of a mini-series called Let's Learn Rust. For those of you who are hearing about Rust for the first time right now, it's a language that's been in 1.0 for a few years now, and it aims to be a significant improvement over a language like C++. Rust, like C++, is a high-performance, statically typed, and ahead-of-time compiled language. Two significant improvements that Rust makes are, first, there's no need to directly manipulate memory in Rust like you would do in C++, so with that, you get really strong memory safety guarantees. What this does in effect is it makes it so you'll never access memory that is invalid, which means a proper Rust program should never segfault. And it does this through a really strict compiler and compile time checks. If you write code that could possibly segfault, the compiler is going to reject it and make you fix it. In this video, we're going to look at a total of 4 things. We're going to look at how to get Rust installed, we're going to look at their cargo and crate system, we're going to look at what a typical Rust project structure looks like, and we'll try to get like a hello world program running. So let's jump in. Rust runs on tons of different platforms, so whether you're on Linux, Mac, or Windows, or otherwise, head to this link here. If you're on Unix like OS, which includes also Linux and Mac, they offer a one-liner which you can just copy into a terminal and install it like that. This is definitely the easiest way. So I will open my terminal here, and I will run that. It says downloading installer, proceed with installation. I'm going to pick number 1. And then it's done. Now mine finished instantly, but yours might take a minute or so depending on your internet connection. I already had mine installed. If you're on Windows, there's an exe file you can download here, rustup-init.exe. Download that to your system, double click it, and follow the on-screen prompts to install Rust. If you're using the Windows subsystem for Linux, then the one-liner that's used for Mac, Linux, and other Unix-like operating systems is the exact same for the Windows subsystem for Linux. To verify Rust is installed, open your terminal and do either rustc-version or cargo-version, and you should see the name and a version number there. If you do see that, then Rust is installed. There's 2 tools that we're going to look at. The first is rustc, which is the Rust compiler, and then there's cargo, which is the Rust build system. I have a very basic Rust program here, which all it does is print out hello world. If I want to compile this, I can come to my terminal and I can use rustc. So I do rustc and I specify the name of the file, and then it will create a binary in that folder called test. When I run test, I can see I get the output that I expect. It says hello world. The second thing we're going to look at is cargo. Rustc is fine if you have a couple files, you can compile them, it's no big deal. But imagine you have a larger project with a bigger kind of file structure that contains, say, hundreds of files. You're not going to want to use rustc on all that. So they offer cargo, the build system, to allow you to just build it all in one command.
Oh yeah, that's maybe it was this video. I don't think it was this video, but yeah, it was a tutorial, a playlist from what I remember. Where rustc compiles and then run. No, there was another. Oh, you can just call the file after it's compiled. As far as I remember.
Installation, I'm going to pick number 1. And then it's done. Now mine finished instantly, but yours might take a minute or so depending on your internet connection. I already had mine installed. If you're on Windows, there's an exe file you can download here, rustup-init.exe. Download that to your system, double click it, and follow the on-screen prompts to install Rust. If you're using the Windows subsystem for Linux, then the one-liner that's used for Mac, Linux, and other Unix-like operating systems is the exact same for the Windows subsystem for Linux. To verify Rust is installed, open your terminal and do either rustc-version or cargo-version, and you should see the name and version number there. If you do see that, then Rust is installed. There's 2 tools we're going to look at. The first is rustc, which is the Rust compiler, and then there's cargo, which is the Rust build system. I have a very basic Rust program here, which all it does is print out hello world. If I want to compile this, I can come to my terminal and I can use rustc. So I do rustc and I specify the name of the file, and then it will create a binary in that folder called test. When I run test, I can see I get the output that I expect. It says hello world. The second thing we're going to look at is cargo. Rustc is fine if you have a couple files, you can compile them, it's no big deal. But imagine you have a larger project with a bigger kind of file structure that contains say, hundreds of files, you're not going to want to use Rusty on all that. So they offer Cargo, the build system, to allow you to just build it all in one command. So to create a new Rust project, create a folder. I created one called A080, and then inside that run cargo init. When I ran cargo init, this created a couple things of interest. The first, it created a source folder which contained all my Rust source files, and then it created a cargo.toml. If you look in the source file, we see one file called main.rs, and we see the contents is actually exactly like my test file. Inspecting the cargo.toml file, we can see that it contains some metadata about my project as well as a section called dependencies. Dependencies is where you would add any crates that your program might depend on. Now crates, you say, what is that? Well, crates is the Rust package repository that contains tons of pre-built code that are packaged into these things called crates. We can pop up in our browser and go to crates.io to see a list of these. Now, this is the exact same concept as like Python pip or Node.js's npm or any other kind of modeling system. So say I found a crate I wanted, something like say, log, Rust library providing a lightweight logging facade. What I can do is if I want to include this in my project, I can simply copy this right here and then drop it onto dependencies. The next time I run cargo run, it will automatically download that dependency to my system. This point I'm ready to run my project, and I do so with cargo run. Now before I click enter, cargo run does two things. First thing it does is it downloads any dependencies that's changed, removed, or added since you've last ran your program. And the second thing it does is it compiles everything in your source directory and then actually runs it. So let's do cargo run and see what happens. You can see they updated the registry, downloaded the actual log crate, and then ran the program. Using cargo has another added benefit in that if you were creating your own crate, then it would already be in the format to be able to get published to crates.io. Now remember I said that cargo will compile and run multiple files together, so I add a second file here called hello.rs. I put a function called say hello, and then I'm just outputting hello again. Back in my main file, I'm using that file to say hello a second time from the main file. I now have two .rs files, but it doesn't matter because when I come to my terminal and I do cargo run, it just compiles everything together and it runs properly. And don't worry if you don't understand the syntax, we're going to go into depth in a lot of that in future videos. However, one thing I will say is just like the main function in C or C++ or Java, the main function in Rust is the main function that will run as soon as you execute your binary. This becomes the entry point to your application. And that's it for this video. In the next video, we're going to pick up exactly where we left off and we'll start digging into the actual core of Rust and start looking at language features as well as other syntax. If you have any questions,
Getting features out faster sometimes requires sacrificing project organization. Further enhancements to your project start to slow you down, and changing behavior gets harder and harder. Rust lets you split a package into multiple crates and into multiple modules. My name is Ricky, and this is the dev method. By managing project in Rust, we're going to look at packages, crates, and modules. So far, we've written things only in the main.rs file. For very large projects, Cargo has workspaces. Those are covered in chapter 14 of the Rust programming book, so you can take a look there if you want to skip ahead. In this video, we're just going to cover the basics. Packages is a feature of Cargo for building, testing, and sharing crates. Crates are a tree of modules that produces a library or executables. Modules and views let you control organization, scope, and privacy paths. Paths are a way of naming your items, maybe structs, functions, or modules, along with other Rust stuff. So a crate is either a library or an executable. The crate root is the source file that Rust needs to know where to start your module. And a package is at least one or more crates.
Hey guys, my name is
Package
Spencer.
has a cargo.toml file. In my example here, we have the package, as you can see listed here, and then the name of that package, our version, our edition of Rust to be using, and then its list of dependencies. So I happen to have here a main.rs file, and that keys us in that this is a binary.
Hey guys, my
If
name
it's
is
a
Spencer.
lib.rs file, that means it's a library. And you can have multiple binaries in the source/bin folder. So all of our source code will be actually scoped under crate, and this will be our crate. So for example, when we had the guessing game and the pitfall game, we had a dependency called rand. This is so that we could use the range struct, so RNG. So if we want to use it in our source code, this is what it would look like. So we had rand under the dependencies, and then we use this double colon to get to this RNG struct. So with this example, never mind the squigglies underneath things, I'm just saying that the code isn't used yet. So the Rust programming book actually uses a restaurant as a way to like model different modules and scope. So we're going to use that here in our example. So I want to call your attention to line number 5 because we have here front of house, and within front, so front of house is a module that's notated with mod for module. And then we have mod hosting, so we have a module within a module, so that's cool, we can do that. And then we also have functions. Now the function could also be outside, it doesn't have to be nested in double modules like this, and it could also be not inside a module at all. But for our examples going forward, this is going to be the structure we start with. Now we use the modules not just for organization, but to control our privacy, so we have either public or we have private. Public means that anybody who's using this crate in the future is going to be able to access that function or that struct or that item that you want to grab. This is what the modules are doing. So,
Yeah, I remember
you can
seeing
absolutely
this
map starting
video.
from the very first lib order to get. You just mark it with pubs and the relative as well. And then and we marked an enum as public. Not all of it's very will work because standard
I
library
don't
here.
think I'm
Only
gonna
have
watch
an example.
this again.
Welcome back to Let's Get Rusty. My name is
Probably not gonna watch the other ones as well. I still don't understand that really well. I get all these things, but I'm curious about how it works under the hood, what's happening under the hood when I run the commands. Like where does it store the files by default? And where should I run the command by default? And I guess I understand here you can pass /p to select a different package, and I guess you put the directory that the other package is. It's just a little bit confusing. And those usually are the hardest questions to find from my past experience. Because the other stuff, there are videos and articles, but I think to find out what's happening under the hood is a lot harder. Maybe the video from
I can
that
find
guy
just
is
something
gonna
to build.
help. This guy here.
Today we're going to be looking at the new module system that was added in the Rust 2018 edition. A lot of people found the original module system to be a bit confusing, especially when they first started working with Rust. In an effort to make it a little bit easier to understand, they've added a lot of new features that make it much more intuitive. Now, first of all, I recommend that you guys go ahead and update your version of Rust so that you can use these new features. And to facilitate that, I recommend that you download the RustUp tool if you haven't already. RustUp will allow you to have multiple different Rust toolchains on your system at the same time, so you can have the nightly toolchain and the stable toolchain at the same time. Also, I won't be covering every little niche case in the module system, so you can come to this edition guide and check out some of the new changes. Now, there are a lot of changes to Rust 2018 outside of the module system, and we will get to some of these in their own videos. For instance, I'm going to make a video on futures and streams, and I'm also going to make a video on the new trait system and the new lifetime modifiers. With that out of the way, if you've gone ahead and you've created a new project with Cargo on the latest version of Rust, you'll notice that inside of your cargo.toml, you'll have a new key called addition, and the addition will be by default set to 2018. If you're working with an older project, you can go ahead and add this key and then add 2018 as well, and then that will give you access to these new features. Now, as far as I know, most of these features are not breaking changes, so you should be able to still use the old 2015 notations without any problem. There might be some small use cases where you do have some kind of breaking change, so I do recommend that you migrate your code from 2015 to 2018 fairly slowly. There's also a tool that you can use which will take 2015 code and change it into 2018 code, and I'll link that tool in the description of this video so that you guys can go and take a look at it. Now notice for this project, I've imported two libraries, Lazy Static and Rand, and we're going to use these two libraries in our example. So in Rust 1.0, if you wanted to bring in an external library, you would have to use the keywords
The
external
documentation does have a lot of stuff though, and from what I've seen so far, it's pretty good.
and create, followed by the name of the library. And if the library had macros that you wanted to use, you would have to use this procedural macro above the import to tell the compiler that you want to bring in those macros as well. None of this is necessary anymore. So instead of calling extern crate, I can go ahead and just say use, and then the name of the library. So in this case,
I already watched this video as well. I don't think I'm gonna watch this again.
So, welcome everybody to a
I'm gonna do the Italian thing here. After that, I'm gonna start the tutorials from the main project, and then I'll think about then after stream, I'm gonna stop streaming, then I watch this video as well. I eat, and then maybe I come back here to continue to work on the other stuff.
Sono
Sono,
I basso am. Io
io,
I
i,
il trattino basso suo.
io so,
HIS. Che
che,
det. Lui
lui,
è. Era.
era,
È. She-basso was. Per.
per,
For. Su.
su,
On. Come.
come,
As. Li che. Con.
con,
With. Loro.
loro,
Dei. Essere.
essere,
Tu-basso be. A.
a,
At. Uno.
uno,
One. Avere.
avere,
Tu-basso have. Questo.
questo,
This. Da.
da,
From.
from,
Di.
di,
By. Caldo.
caldo,
Hot. Parola.
parola,
Word. Ma.
I'm gonna make this faster because it's too slow. I'm gonna put 1 second. And also, it's kind of annoying when he says the English word. It would be better if I just printed the English word. But the problem is it's gonna take too long, I think. The other thing that I was thinking about is I can just create the different CSVs manually for the amount of words that I'm gonna repeat each time instead of figuring out a program, since it's not something that I'm gonna spend a bunch of time with. I just did it more for learning Rust and getting more familiar with the concepts. So I'm trying to think if there's an easy way to make it so that it only says the Italian word instead of the English one. It would be optimal if it said the English words in English and then the Italian in Italian, but it doesn't work that way. Whatever, I'll think about this another time.
Sono.
Sono.
I trattino basso am.
Non lo so.
Io.
Io.
I. Il trattino basso suo.
Il trattino basso su.
HIS. Che.
Che.
Det. Lui.
Lui.
È. Era.
Era.
È. She trattino basso was. Per.
Per.
For. Su.
Su.
On. Come.
Come.
As. Li che. Con.
Con.
With. Loro.
Loro.
Dei. Essere.
Essere.
Tu trattino basso be. A.
A.
At. Uno.
Uno.
One. Avere.
Avere.
Tu trattino basso have. Questo.
Questo.
This. Da.
Da.
From. Di.
Di.
By. Caldo.
Caldo.
Hot. Parola.
Parola.
Word. Ma.
Ma.
But. Cosa.
Cosa.
What. Alcuni.
Alcuni.
Some. È.
È.
Is. Quello.
Quello.
That. Voi.
Voi.
U trattino basso. PL. O.
O.
Or. Aveva.
Aveva.
Ed. Il.
Il.
Te. Di.
Di.
Of. A.
A.
Tu.
Tu.
E.
E.
And. Un.
Un.
A. In.
In.
In. Noi.
Noi.
Ui. Lattina.
Latina.
Ken trattino basso. Of trattino basso soda. Fuori.
Fuori.
Out. Altro.
Altro.
Other. Erano.
Erano.
Were. Che trattino basso quale. Which. Fare. Tu trattino
Fare.
basso do.
Fare.
Make. Loro.
loro,
teir, tempo,
tempo,
time, se,
se,
if, volontà,
volontà,
will, come,
come,
how, detto,
detto,
said, un, an, ogni,
on,
each,
ogni,
dire,
dire,
tell, fa,
fa,
does, fisso,
fisso,
set-basso, unchanging, 3,
tre,
tri, desiderare,
desiderare,
desire, aria,
aria,
bene,
bene,
well, anche,
anche,
also, giocare,
giocare,
play, piccolo,
piccolo,
small, fine,
fine.
and, mettere, put,
I think I just had
Ca-
an idea. Can create two instances of the narrator. Yeah, but then how? The problem is how would I know? Yeah, I guess I can divide by two. I think I'm gonna try that. Yeah. The other thing that I just thought about is changing the other file so that I don't have these underscores, because Trattino I think is underscore and it's kind of confusing when he says it like that. So that could be something that I can try, because not replacing with an underscore messes up the CSV for looking visually. But I think for reading, it's not gonna have any difference. It's not gonna make any difference. I'm just gonna put true here. Then I'll run this later and then I'll test it out. But first, I think I'm gonna try to copy this and paste. Oops, it's like this. And then create a variable here. Or maybe, I think U8 only accepts 356. But the other thing that I'm thinking about is, after, if I make this work and then make the other one work as well, I'm gonna take the final CSV and I'm gonna manually separate into 9 other ones, to 10 or 20 other ones actually, and do 50 words each day. Because I think that's gonna be, I can do 50 and then repeat 50 as for 10 minutes. I think that's gonna be better, because more than that I think is a little bit too overwhelming in the beginning. And then once I feel comfortable with the first 50, then I jump into the next one. Then I think you would go after this one, because it's inside of the loop. So just do count plus equals 1. And I have to put mute here as well. And then inside of this, I make I'm thinking about whether or not it's better to do a match, so I can put the string, but it has to be different than string. It's easier to do if statements, I think. And here I'm gonna put 1, so it's easier, because I'm gonna divide by count. So if the remainder is different than 2, then I use the English one. Yeah, I think I'm gonna do it like this because it's easier. Well, I don't have a variable that counts. Oh no, yeah, what I'm thinking about. Counts divided by 2. Let's see if this works.
Sono.
Sono.
I_am.
It doesn't work.
IO.
I.
Il_suo.
Oh, it works, but it's
HIS.
the different condition.
Sono.
Sono.
I_am.
Io.
Io.
I.
Il_suo.
Io
His.
suo.
Che.
Okay, now the other thing is I'm gonna try to run this one. Maybe I should try to run with a flag there. But then I don't know how to specify that. Let's try one up. And then source, maybe. In workspace. Oh, I have to do the thing that the guy was talking about. I put the workspace here and then put the directory and then put the file name. Yeah, so I'm not gonna do that. And maybe I should, but yeah, not that big of a deal. Now this I'm pretty sure that, or maybe not. Oh, so it's probably because I changed the names. So it does work when I run from the other directory. But it's because where is it? When I did the conversion there, I changed the name. I'm pretty sure. Yeah, to H. Yeah, so it's the same thing as the other one, but with no underscore.
Sono.
Sono.
I am.
Okay.
Io.
I.
Il suo.
His.
Che.
That.
So I'm gonna make this one be the second one, and I'm gonna use this one as the first one. I'm not gonna delete it because there's no point in deleting it, I think. But it's much better that way. And now I think I'm going to separate the file here into 9 other ones and change the directory. Thanks for the follow. I think I can delete this as well. I think DD deletes a line in Vim. There was a way to... I just watched the video, the guy explaining a way to copy multiple lines, but I don't remember really well. But I know that this one copies, and then I can just do... and this. Y. And the command that I want to look for is how to copy and delete. I'll look at this later. But it's one that I'm feeling that is gonna be very useful. Hey, computer Sky. Nice. A50. Maybe 50. Maybe I should put more so I don't have to manually create a bunch of CSVs. I guess I can create another program to create the CSVs. But I think that's gonna be too much work because then I'm gonna have to figure out the packages and the module and then how to run the file from the module. And I think creating the files is simple because all I have to do is create the command there that I used on the other one to open the file and to create it if it doesn't exist, but okay, Italian one to just gonna do this manually, whatever. So 1, 2, 3, 4. Have a better idea. I'm gonna put some musical in the background for myself. I'll do this boring stuff. Okay, one's done. Oh no. Nice. 3. Oh. And 50. Oh, I think I missed the final one. Whatever. Just copy melody. It's gonna take some time, but it's worth it because I only have to do this once. Oh. This is up to 200, so I think I'm gonna repeat the last one because it doesn't matter anyway. Oh no. There's probably a command so that I go to the last line that I was, but I don't know the command. Two 50. 300. 650. Hopefully I didn't mess anyone of them up, but I think I did everything correctly. I just realized that I could have done this from the beginning. Shift L goes through the end of this screen there. Oh, nice. Yeah, whatever. I think he's missing one of the words at the end, but it doesn't matter at all. I think this is more than enough to have a good foundation. And it's probably I'll think about other methods once I understand all of the words from this list, but I think it's gonna be probably enough to understand what people are speaking or talking about. I watched a little bit of a video in Italian of a guy, a C tutorial, and I could kind of understand what he was saying, even though I didn't study at all. So I think it's pretty similar to Portuguese, so it shouldn't be hard to learn, the basics at least. So this 1,000 words should probably be enough, but if I want to go further, then I'll think about maybe I'll search more words on other sites, or yeah. I'll think about another thing to do. I think one interesting idea maybe in the future, but this is very in the future, depending on a bunch of other stuff and how does the other chain data project goes. But I think what I could try to do, and should be interesting, is to do the same web scraping thing that I did, but for the other side, but for this side, for Monkeytype, and then create an automation tool that runs the tests, restarts the tests, and scrapes all these different texts here from the language. That should be interesting. But it's gonna be a lot harder because it's gonna require JavaScript, so it could be too hard for it should be worth it. Because it's obviously easier to build these things in Python, I think. And for some reason, typing, I think it's because of the position of the letters of the words, but typing in Italian is a lot harder than typing in English. Maybe it's just what I'm used to more, but it feels like the words in English flow more naturally because of the finger placements. They're more distributed, I think. Yeah, but now I'm forgetting how to type in English as well. Oh, whatever. So let me see. Yeah, so I'm gonna do the 50 words now, and then I'll continue to do what I was doing before. Let me put the volume up.
Io,
Io,
I,
il suo,
il suo,
his,
che,
that,
lui,
che,
he,
lui,
era,
era,
he, she was,
per,
per,
for,
su,
su,
on,
come,
come,
as, like,
con,
con,
with,
loro,
loro,
they,
essere,
essere,
to be,
a,
a,
at,
uno,
uno,
one,
avere,
avere,
to have,
questo,
questo,
this,
da,
da,
from,
di,
di,
by,
caldo,
caldo,
hot,
parola,
parola,
word,
ma,
ma,
but,
cosa,
cosa,
what,
alcuni,
alcuni,
some,
è,
is,
quello,
quello,
that,
voi,
voi,
you, place,
o,
o,
or,
aveva,
aveva,
had,
il,
il,
the,
di,
di,
of,
a,
a,
to,
e,
e,
and,
un,
un,
a,
in,
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 noi,
noi,
we,
lattina,
latina,
can, of soda,
fuori,
fuori,
out,
altro,
altro,
other,
erano,
erano,
were,
che, quale,
che quale,
which,
fare,
fare,
to do, make,
loro,
loro,
there,
tempo,
tempo,
time,
Se.
Se.
if,
Volontà.
Volontà.
will,
Come.
Come.
how,
Detto.
Detto.
said,
Un.
Un.
an,
Ogni.
Ogni.
each,
Dire.
Dire.
tell,
Yeah, there we go. Nice. Yeah, so let me start the other one. I have to remember which folder. I think it's this one. Yeah. And open at this level. I don't remember what this is, but oh, this is from monkey type. Just data frames that I downloaded, but remember I was gonna do something with them, but I don't think I'm gonna do that anymore. Yeah, so I'm gonna follow the tutorial from the other guy. Maybe I'll watch the Vim video. I think I'm gonna search for the command actually. I wanna copy and delete, yeah. Copy and delete. I was considering buying this subscription here for a month and maybe I will still do. Maybe I can learn everything in 1 month if I go really hard, but I'm learning one command at a time and it's kind of easier than I thought it would be, to be honest. I think I already got the main ones down, the beginner ones, the fundamental ones. And now incorporating some commands as I need them, which I think is a lot easier to remember because since I'm using it all the time, there are a lot of things that I want to do and I can't do. So I have to search how to do it. But it might be worth it to just pay because it's really cheap, just $8 for 1 month. So I'm considering. I think it's probably worth it actually. And maybe I don't think there will be a problem to string doing that because the point of buying is to use it, obviously. So I don't think it will stop people from buying, but or maybe it will actually. I have to think more about that. Maybe I should send them an email or something like that to see if it's fine. But I think this is really good to remember the commands. And it's probably going to be a lot faster than knowing one by one, especially because there are things that I don't know that I don't know, so I think I can I don't need to train this anymore, the basic ones. I think I'm gonna send them a message. If they allow me to stream this, I think I'm gonna get it. I think 1 month is enough to. Uh, 1 month should be enough to learn everything that I need. Maybe true, but then $16 is not that much. And I think for the amount that I'll gain is probably worth it. And there are there are shortcuts for VS Code, I think, which are gonna help me a lot probably. I just send them a message. If they don't allow me to stream, then I'm probably not gonna get it.
Let's focus on fast technical videos. Today I'm going to help you build your own Rust toolchain by swapping out parts you don't need with parts you do until you have an elegant weapon from a more civilized age. As with building any lightsaber, we're going to start with the housing, batteries, and core, then move up to the focusing crystal and dials where we can really make our mark. As you know, there are many kinds of lightsabers, from basic ones to Swift or even groovy ones. Today we are building a Rust lightsaber.
Because
Let's get started.
it is obviously a lot more convenient to do this while I'm streaming. I don't want to have to stop the stream just to train and then come back.
Lightsaber, you start with the primary crystal. Many people use a Ruby, but we're going to use Rust. Install yours with rustup.rs. If you're on Mac, Linux, or WSL, your method will be the script. For Windows, there's an installer on the website. This installs the entire toolchain. Rust C, the compiler, Cargo, the build tool, Clippy, the linter, Rust format, the audio formatter, and documentation tools, among other components. Just having a language installed won't do much without a powerhouse of an editor. Many are available. If you don't know where to start, Visual Studio Code is an excellent place to. Emacs with Spacemacs or Doom is great too, as is Vim or NeoVim. The key thing is to make sure whatever editor you choose has first-class support for LSP, the language server protocol, which we'll talk about in a minute. This means you will have access to all the features I do. I'm going to use NeoVim, the lightest LSP-powered editor. If you want a fantastic out-of-the-box experience with no configuration, I recommend Astro NVim, which has terrific defaults and incredible Rust support. Once you install it, which is a simple Git clone, there's a graphical LSP selection process which handles everything you need to get language support running. After installation, you'll have a minimal Rust IDE with all the power of LSP. This represents the most lightweight setup I can think of, and is what we will build upon today. If you have VS Code or another editor, you'll have the same functionality, but a bit more Chrome. We're now going to tweak the focusing crystal of our lightsaber, which is to say, the theme. Though we got very far with Astro NVim, we're going to take it to the next level with Neovide. Neovide, a portmanteau of NeoVim and IDE, provides ligatures and font shaping, animated cursor, smooth scrolling, animated windows, blurred floating windows, and most importantly, emoji support. It can also connect over sockets to a remote instance of NVim, handy for cloud use. All of this is rendered on the GPU with OpenGL, and is the fastest editor I've ever used. Neovide is what I have built my lightsaber around, and I do hope you will too. But whatever editor you choose, I recommend that you get one that supports LSP. Though there are heavyweight IDEs such as Eclipse and IntelliJ that use their own proprietary static analysis tools, the one that seems most used in the open source and Rust worlds is LSP. NeoVim has built in LSP support, and the Rust toolchain that you just installed with RustUp came with an LSP server. The LSP plugin we will be using is the new de facto standard, which is called Rust Analyzer. It started off as a fork of the official LSP server, and has now become the officially recognized one. Your install of RustUp will very likely come with it by the time you watch this. If it doesn't, then you'll have to use the nightly toolchain for a few weeks. Let's plug in a REPL. While Rust has almost no runtime, certainly compared to dynamic languages, you can have a REPL because Google was so nice as to build them for us. EVCXR, a badly named tool that is impossible to remember the name of, is a REPL kernel that can be used at the command line or in a graphical Jupyter session in your browser. Behind the scenes, it's just wrapping your code up in a main function, compiling that file, and printing the output. I'm including it here because many of my fellow recovering dynamic language addicts will feel relief knowing there's a REPL to fall back on. By all means, install it. I did, but you won't need it. Rust's compiler feedback available in editor using LSP is so rich, you'll forget all about the REPL. It's worth pausing for a moment here. Something special is happening. Not only does Cargo let you manage your Rust, all the incredible richness of LSP, though non-overlapping purpose, it's a second brain, such as these mermaids diagram. It's used by all my stuff and well-formatted error reports for all kinds of errors, and a really cool view of all your notes and the links between them. All native functionality is available in there. It is the Rust compiler sends me that warms my heart. I like to see both. They can run your tests, or build, or Clippy, or any of the Cargo commands, including documentation building, and you can switch between them by pressing T, or R, or C, etc. The real magic is that it picks up changes seemingly instantly with no flickering. It's the smoothest example of this I've ever seen. An alternative I've used is called Cargo Watch, which provides a similar, though non-overlapping feature set. Try Bacon first. Next is LazyGit, or its Rust equivalent, Git UI, which I discovered through its integration with Astro NVim. This lovely Git UI is just a space GG away. Do note Neovide's transparencies here. However, they're both normal terminal programs and can run in any Git repo. It almost makes me forget my time with Emacs's Magit. Almost. Now we've set up our editor, we can talk about actual Rust development libraries. But before I do, I'd like to thank Obsidian, the Markdown knowledge base, without which my videos and much of my life would not be possible. Obsidian is a powerful knowledge base built on top of a local folder of plain text Markdown files. If you've ever used Notion or Roam or Evernote, it fills a similar purpose. It's a second brain for you forever. Craydon Hall, whom you might recognize as the creator of Rust, has this to say on the topic of Obsidian. I couldn't have put it better. Hypertext was supposed to link our thinking together, and Obsidian realizes this. You can think of Obsidian as a Markdown IDE with plugins galore. Here is my exact setup that I'm using to edit this script right now. At the top is a Kanban board, which is simple Markdown behind the scenes. The Reveal.js powered advanced slide plugins preview is in the upper left quadrant, with the Markdown source code on the right. I had this source code open twice, again in the bottom left, as I was noodling with the font sizes quite a lot, as they're in the front matter. Finally, the outline is on the right, along with the checklist plugin pulling out Markdown checklist items from the current document. Though if you don't want to use plugins, there's plenty of native features, such as these mermaid diagrams, and a really cool view of all your notes and the links between them.
That's really interesting. It looks a lot like the Network X graphs, so I think I'm definitely gonna check this out. But I'm not sure if it works for creating arbitrary graphs or just for the
Magit, almost. Now we've set up our editor, we can talk
stuff
about
he's talking about. Okay, so
Sottolineare. Sottolineare.
about actual Rust development libraries. But before I do, I'd like to thank Obsidian, the Markdown knowledge base, without which my videos and much of my life would not be possible. Obsidian is a powerful knowledge base built on top of a local folder of plain text Markdown files. If you've ever used Notion or Roam or Evernote, it fills a similar purpose. It's a second brain for you forever. Graydon Hall, whom you might recognize as the creator of Rust, has this to say on the topic of Obsidian. I couldn't have put it better. Hypertext was supposed to link our thinking together, and Obsidian realizes this. You can think of Obsidian as a Markdown IDE with plugins galore. Here is my exact setup that I'm using to edit this script right now. At the top is a Kanban board, which is simple Markdown behind the scenes. The Reveal.js powered advanced slide plugins preview is in the upper left quadrant, with the Markdown source code on the right. I had this source code open twice, again in the bottom left, as I was noodling with the font sizes quite a lot, as they're in the front matter. Finally, the outline is on the right, along with the checklist plugin pulling out Markdown checklist items from the current document. Though if you don't want to use plugins, there's plenty of native features, such as these mermaid diagrams, and a really cool view of all your notes and the links between them. All native functionality is available on their free mobile app too, along with many of the community-made plugins. Obsidian is freeware, available on Linux, Macs, Windows, and Android and iPhone too. My thanks again to the Obsidian team for building this incredible app. Finally, some Rust. My recommendations come in two parts. The first are built into your lightsaber, i.e. you should use them in nearly all of your projects. And the second are tools for your tool belt. Let's talk about some essential libraries. Tokyo is the most popular async runtime. If the framework you're using gives you a choice, probably your life will be easier if you use Tokyo. It's used by all my subsequent async recommendations here. Rust's functional roots mean that there are no exceptions that would take you out of the flow of functions. Rather, errors are passed by value, using our old friend, the results enum. As I've explained in previous videos, results either contain the value you want or an error with more information. Errors can be multiple types from different frameworks, so type signatures can get a little cluttered, as they list all the kinds of errors you might return from a function. Air unifies this under one results type, in addition to other useful properties, such as color error, which is an error report handler for colorful, consistent, and well-formatted error reports for all kinds of errors. For me, the reason all my programs use this is that it brings Rust's runtime exceptions up to the same high standard as the compiler exceptions. Sensible logging is a must for complex applications, and because Rust allows us to fearlessly make concurrent programs, we can't just print out stuff and expect all the threads to line up nicely for us. Tracing is a framework for instrumenting Rust programs to collect structured, event-based diagnostic information. Now you've built your main weapon, your lightsaber, it's time to accessorize. These are tools that you should have on your tool belt ready for use at a moment's notice. We'll start with Request. Request is a batteries-included HTTP requests library. It's spelled a little weirdly, because if they named it the correct way, our lives would be painful trying to Google anything. Every language seems to have a request library, doesn't it? And this one is at least spelled uniquely. Request has both sync and async methods. The default, and one we're using here, is async. Make sure you copy the right examples. Welcome to Fearless Concurrency. Rayon is a data parallelism library for Rust, which makes it trivial to convert sequential iterators into parallel ones. For example, here we've just changed the input.iter call into input.pariter, and Rayon does the rest. Rayon taps into Rust's powerful type system with guaranteed data race freedom. Amazon are one of the many companies taking Rust seriously. Here we're querying our DynamoDB table names. Amazon also generated this SDK from Smithy models that represent each AWS service. I didn't learn what that means, but it sounds good, doesn't it? Links in the source code for the curious. Clap is the most popular command line args parsing library. It seems to get more and more featureful each time I look at it. This example here uses the clap app macro to make your config extremely small. However, you can use the normal functional builder pattern, which this macro unpacks to, or even find it in a YAML file unpacked and checked to compile time by clap's low YAML macro. Personally, I like to keep things pure Rust. SQLX is my favorite SQL framework. No ORMs, no layers in your way, just compile checked SQL, as I've demoed multiple times in previous videos. Here, as a change, is the non-macro way to query your DB using SQLX. Fully async, pure Rust, even down to the database drivers and Rust version of OpenSSL. Lovely. Chrono is a strict ISO 8601 times.
I was 100% sure that they use Vue.js to do that. The graphs look exactly the same. That's why it caught my attention. But I think I won't be able to use it for other things other than Markdown thing. It's probably not that fast for the things that I want to do, which is to display large amounts of data in the browser. There are probably other Rust libraries that are way better for that, for using. I'm gonna have to look into assembly. And I think it's probably a better idea to do with Rust. Try to do the display of graphs with Rust and WebAssembly. Then to try to do it with Django or any JavaScript library, because I think it's gonna be faster with Rust, but I'm not really sure. And I think WebAssembly doesn't have a lot of stuff yet, so it might be different than I'm thinking. But for now, that's how I have it in my head. The front end, I can use JavaScript. I put JavaScript and the smart contracts in the front end portion of the project. Then the backend or the machine learning and backend can be Python if I don't change it to the backend to Rust. And then Rust, I can do the data gathering and data analysis. And I think that's gonna be the best way probably to do it.
Nothing fancy, but you're going to need it. There's a few GUI libraries available in Rust at the moment. Tori is a huge project, but you have to write your app in JavaScript, and that doesn't spark joy for me. eGUI here is pure Rust, runs at 60 FPS, and is not reliant on native.
Yeah, but then and then I can instead of doing the visualization from Python backend, I can do the visualization on Rust, and then yeah. But the problem, but I think I can. It's not that hard actually. Probably, I can create a serverless function in Next.js and then connect with Rust API or Rust, do the Rust requests to send information. Yeah.
Native C libraries, which means it's portable and even runs in WebAssembly. If you want to write native HTML, however, you want U. U is a reactive WebAssembly-powered UI toolkit that is faster than React.js.
It would probably be easier though if the backend was on Rust and backend on Rust, frontend in Next.js, and then I do the machine learning in Python only instead of doing the Django backend. But I'm gonna think about that after I get the data with Rust and then think about the data analysis. It's probably better than to just think about this stuff now, because I also don't know how hard it's gonna be to do authentication and authorization with Rust. In Python, it wasn't easy, but I had no idea what I was doing in the beginning. And then I had to learn everything. But now that I have a decent idea of how it works, I think it's not that hard actually.
TypeCheck has native HTML support, thanks not to a preprocessor like Babel, but Rust macros.
Obviously, understanding the source code is the hard part, and how all the libraries and dependencies go together. But to understand how to use the library is pretty easy.
Is you should set up Clippy for your project with some sensible defaults. If you're coding for yourself, I recommend enabling as much as possible, like I've done here. At minimum, I want you to turn on unwrap used and expect used warnings. I consider use of unwrap and expect as shortcuts to get your code working quickly, but I never commit them. Think of them as to-dos in your code. You now have everything you need to go out into the world and start one there. See, it's more your bag.
Yeah, so I think I'm gonna stop here, and I'm
Okay, so
gonna
this video's gonna
go have lunch, and then I'll come back today and start the. Unfortunately, I couldn't start right away because all the other stuff that I thought was wrong. But I'm gonna watch some of these videos off stream while I eat, and then I'll probably come back in a few hours to start this tutorial here and start working on the chain data stuff. So see you then.